Welcome to Want to Learn Chemistry, a site to help you become a chemistry expert. Today you will be learning about chemical reactions. Start activity. The chemical formula for ethanol is written as C2H5OH. Question 1. How many atoms of hydrogen are there in an ethanol molecule? Question 2. How many different elements are there in an ethanol molecule? And question 3. What is the total number of atoms in an ethanol molecule? Pause this video and go through the questions. Now let's go over the answers. The question was, the chemical formula for ethanol is written as C2H5OH. How many atoms of hydrogen are there in an ethanol molecule? And the answer is 6 hydrogen atoms. Question 2. How many different elements are there in ethanol? And the answer is 3 different elements, and they are carbon, hydrogen, and oxygen. Question 3. What is the total number of atoms in an ethanol molecule? And the answer is 9 atoms. Today you'll be learning how to represent chemical reactions as word and symbol equations. To achieve a grade D, you need to be able to write chemical reactions as word equations. To achieve a grade C, you need to be able to write chemical reactions as symbol equations. To achieve a grade B to A star, you need to be able to balance symbol equations. In a chemical reaction, the atoms get rearranged. You can think of them as swapping partners. Example: calcium carbonate decomposes, breaks down on heating to form calcium oxide and carbon dioxide. The word equation for the above reaction is calcium carbonate arrow calcium oxide plus carbon dioxide. The symbol equation is CaCO3 arrow CaO plus CO2. Balancing equation. Make sure that the number of atoms on the left is equal to the number of atoms on the right. In this case, the equation is balanced. Here, calcium carbonate is the reactant, calcium oxide and carbon dioxide are the products. Why do we need to use symbols? Think about this question. Okay. Now let's see the answer. Using symbol equations help us to see how much of each substance is reacting. Representing reaction this way is better than using word equations for 3 reasons. The first, word equations are only useful if everyone who reads them speaks the same language. Word equations do not tell us how much of each substance is involved in the reactions. Word equations can get very complicated when loads of chemicals are involved. Why balance an equation? Pause this video whilst you think about the question. Okay, now let's go over the answer. Atoms cannot be created or destroyed in a chemical reaction. This is why there must be the same number of each type of atoms on both sides of the equation. This means that the total mass of products formed in a reaction is equal to the total mass of the reactants. Word equation. Sodium and water arrow hydrogen plus sodium hydroxide. And to recap, sodium and water are reactants, hydrogen and sodium hydroxide are products. For the above reaction, the symbol equation is Na plus H2O arrow H2 plus NaOH. To work out what the products are, you need to think about what you start with. How to balance equation. If the masses are not balanced, then the equation is not balanced. Here, each carbon atom has a mass of 12 gram and oxygen has a mass of 16 gram. We do 2 times 12 because we have 2 carbon atoms, and 2 times oxygen because we have 2 oxygen atoms, and we have 2 times 12 because of the 2 in front of the carbon, which belongs to the carbon as well as the oxygen. And the sum here, 56, should be equal to the sum of 24 plus 32, which it does. So this equation is balanced. 4 basic steps to balancing a chemical equation. Step 1. Write the correct formula for the reactants and the products. Do not try to balance it yet. You must first write the correct formulas. Once you write them correctly, do not change the formulas. Find the number of atoms for each element on the left side. Compare those against the number of atoms of the same element on the right side. Determine where to place coefficients in front of formulas so that the left side has the same number of atoms as the right side for each element in order to balance the equation. Step 4. Check your answer to see if number of atoms on both sides of the equation are now balanced and if the coefficients are in the lowest possible whole number ratios. Here are some suggestions to help you. Take one element at a time, working left to right except for hydrogen and oxygen. Metals, then non-metals are a good way, and save hydrogen next to last and oxygen until last. If everything balances except for oxygen, then there is no way to balance oxygen with a whole number. Double all the coefficients and try again. And the reason for this is because oxygen is diatomic. Subscripts versus coefficients. Subscripts tell you how many atoms of a particular element are in a compound. Here, in CO2, the small 2 is subscript. This tells me one molecule of carbon dioxide consists of one atom of carbon and 2 oxygen atoms. Coefficients tell you about the quantity or number of molecules of compound. Here, 3 is the coefficient. Having 3 in front of carbon dioxide means I have 3 molecules of carbon dioxide, each consisting of one atom of carbon attached to 2 atoms of oxygen. In totality, I would have 3 carbon and 6 oxygen atoms. Balancing equations. When balancing a chemical reaction, you may add coefficients in front of the compounds to balance the reaction, but you may not change the subscripts, and this is very important. Changing the subscripts changes the compound. Subscripts are determined by the valence electrons, the ones on the outside that are not being used, and they are not stable. For example, lithium in group 1 has 1 valence electrons, 1 electron in its outermost shell that need to be lost to make lithium become stable. So here sodium chloride exists as Na plus and Cl minus. So sodium chloride exists as NaCl. It cannot exist as NaCl2. So you can't just add a number to a formula to balance an equation. Example 1. Calcium carbonate reacts with hydrochloric acid to form calcium chloride, carbon dioxide and water. Here you can see I've identified all the elements on the left and on the right, which should be the same, and I've also counted the number of atoms of each type of element on the reactant side as well as the product. So far, calcium, carbon and oxygen have equal number of atoms on both sides. Only hydrogen and chlorine differ. Hydrogen has 1 on the left and 2 on the right. Chlorine has 1 on the left and 2 on the right. So as a trial, I'm going to put 2, and I'm going to put 2 in front of HCl. And this balances the equation. In this example, I've done the same thing. I've identified the elements, the reactant and the product, and I've also counted up the number of atoms on the left for each type of element and on the right, and some of them are already balanced, for example sulfur and oxygen and chlorine, and others are not. Hydrogen and sodium are not balanced. So first of all, I'm going to put a 2 in front of HCl, and this balances the hydrogen, but it doubles up the chlorine. So having put front of NaCl a 2, this balances the sodium as well as the chlorine. So now everything is balanced. Example 3. I've done the same thing, identified the different types of elements, the number of different types of atoms in the reactant and in the product, and in this case all of them are already equal, so they are already balanced. The number of atoms on the left is equal to the number of atoms on the right. Here is a question for you to answer. Use the table below, which is on the left, to complete word equations for the reactions. See if you can complete the symbol equation and balance the equation. Pause the video and do this at your own pace. Now, let's go over the answer. Question 1 and 2 has the word equation, the symbol equation, and it has also been balanced. Let's practice some more. Complete the word equation, write the symbol equation, and balance these 3 questions. Pause the video whilst you do so. Now, let's go over the answer. Hydrogen plus oxygen is water. Sodium hydrochloric acid and sodium hydroxide form sodium chloride and water. Methane plus oxygen forms carbon dioxide and water. Now let's do the symbol equation. Are they balanced? Okay, let's look at the first one. First equation is not balanced, and now it is. Second equation is already balanced and does not need anything else. The third one needs balancing, and now it's balanced. More equations for you to practice. Do the same, complete the word equation, write the symbol equation, and balance the equation. Pause the video whilst you do so. Now let's go over the answer. Iron plus oxygen is iron oxide. Sodium plus iodine is sodium iodide. Calcium carbonate plus sulfuric acid is calcium sulfate plus carbon dioxide plus water. Now let's do the symbol equation. Are the equations balanced? Let's see. Now question 4 is balanced. Question 5 is balanced. Summary questions. Now let's go over the summary questions. Question 1 was, why must all symbols equation be balanced? And the answer is, as no new atoms can be created or destroyed in a chemical reaction, the number and the type of atoms in the reactants must equal the number and type of atoms in the products. Question 2 answers. Question 2 asked, a mass of 8.4 grams of magnesium carbonate completely decomposes when it is heated. It made 4 grams of magnesium oxide. 2a, what is the word equation for the reaction? And the answer is magnesium carbonate arrow, magnesium oxide plus carbon dioxide. Question 2b asked, what is the total mass of carbon dioxide produced in the reaction? And the answer is 4.4 grams. Question 3 answers. You have been listening to me at Want to Learn Chemistry, a site to help you become a chemistry expert. Like and subscribe for more videos. Write to me on my channel or email me at wanttolearnchemistry@gmail.com.